This week is full reading days, and I've asked each of you to reach out to me and tell me how I can help you if you would like to meet for office hours, or if you would like to meet over a Google Hangout, or just send me an email and say everything's going fine. So I wanted to take some of the points that we have looked at from these meetups and go over them for the benefit of the entire class. The question I had today is, if we have something like a plant's result activity, how do threads work? So if we have the plant search task, as we see here, we see it's invoking pst.execute. But then when we look at the plant search task, there is no execute method. Well, the idea with threading is that we're not running steps in a sequence, because if we run the steps in a sequence, we have to wait for one step to finish before we can start the next step. That would lead to some inefficiencies in our program. Instead, with threading, we're running two or more tasks in parallel. So while one step is waiting, we can work on another. What the execute method does is it starts a new thread. It starts a new parallel swim lane where we can do this work. And then what it does is this PST here is a plant search task. The execute method is going to start that new thread, and then it's going to invoke do in background, and that's the work that's going to happen in parallel. Okay? In this case, the two processes that we have are, number one, the user interface process. That's the process that's listening for button clicks, rendering images on buttons, so on and so forth. Number two, this do in background is a separate process not related to the interface. Now the trick is, at some point we have to match these two threads back together again. So do in background is going to be running its own process. It was, as we see here on our week 9 videos, it's actually reaching out to the internet and gathering data. When it's finished, it's going to return that data. But return it to where? The data that's returned from this do in background is going to get passed into onPostExecute. This is where the two threads come back together again. This is the way that our background thread is going to tell the user interface thread to update something. So do in background is what happens in the background thread. When it's finished running, it's going to return a value. That value is going to be passed in as a parameter to onPostExecute. OnPostExecute is going to take that value, which in this case is a collection of plants. It's going to pass it to an array adapter. An array adapter marries together some collection of data with our user interface, and then it's going to pass it into the list adapter. It's going to pass it into the user interface. So threads operating in parallel. The reason why this is important is if we did not do this, if we had only one thread, our user interface would be that only thread, and any time we have a long-running task, the user interface would be completely frozen until that task is finished. The problem with freezing the user interface is that the user believes that the application is not responding, and the user is going to keep tapping on that application trying to get it to work. When this happens, Android thinks the application is not responding, and it will then force close the application. Let me show you what I mean by threading, and of course we'll go to our old example. Search by color requires numerous threads. The first thread is it's downloading a mask of colors that it's going to validate against, but we don't need to worry about that too much. Let's start with this screen. Take a look at this screen. Now, when I choose Open Existing Image, I'm going to choose the red bud. When I choose the red bud, it's going to go back to the screen that I just left. But if you watch closely, you'll see that screen is going to be blank for a moment, and then it's going to show colors. The reason why is the selection of colors from this image is very memory intensive. It has to go through and sample the image and make sure that it can display those colors. Then it looks at the top 16 colors that it finds in this image. That takes a lot of work because images tend to be very big. That happens on a separate thread. So if you want to think about that, the sampling of color happens in one of these do-in backgrounds. When it is finished sampling and counting the colors, it calls onPostExecute, and that is what is telling the user interface to go ahead and display the top 16 colors. So I'll click, Okay, now watch, it'll be blank for a moment as soon as it goes back, and on a real device this is much faster. Blank, and boom, color. Did you see that? So it was blank because the user interface was busy recreating the screen, while in the background, a separate thread, a separate task, was counting the colors in this picture and then displaying the top colors on this screen. Then, once it had finished counting the colors and getting them ready, then it goes back to the user interface through the onPostExecute method, and it tells the user interface, here are your colors, please update yourself. Let's watch this happen again. When I click one of these colors, it's going to go to plantplaces.com and find plants that have that color. That's very memory intensive, very processor intensive. So what you'll see is that the next screen is going to show up, and then a moment later a list is going to show up. After that list, it's going to, we're going to see it has a placeholder for the images, which is going to be the Plant Places stylized screen. And then later, the images will show up. And why is that? Because these are actually 2 threads. A total of 3 if you count the user interface. We have the user interface thread that's still available to interact with the user and most importantly, be responsive to the user. And a thread to go get plant results as text, and then a separate thread to go out and download the images for those plants. This took a lot of work, to be honest with you. It took a lot of work. It's 3 separate threads. What's interesting is when I click this color, you'll see the list first, okay? Then you'll see the placeholder P. Okay, we'll watch for the placeholder P. Right now, a separate thread is running, and that separate thread is downloading images, and there are the images. So do you see how it was a sequential, not a sequential process, it was a parallel process there, where what it was doing is it would generate the list to give us some instant feedback. Then after it had the list, it went out and it showed us the colors. But what's interesting is that the UI is still responsive this entire time. And again, on an actual device, not an emulator, it would actually go much faster than that. So I click, and what you'll see that's interesting is I can still scroll and interact with the user interface once the list is up. So you see, while the list is up, before all the pictures have loaded, I can still interact with the user interface. While I'm doing that, the pictures will then show up. And again, how does that happen? The list is one do in background, and when it comes back, it paints itself with an onPostExecute. Then when we fetch the images, that's a separate thread with a separate do in background. And when the images are fetched, it invokes onPostExecute, which essentially says, okay, thank you, go ahead and paint the images now. So the key to this all is that the user interface remains responsive the entire time. Okay? Do in background, that's the thread that's happening in the background. onPostExecute is how it goes back and it tells the user interface, this is what I have, I want you to update. Okay? We start all this by invoking the execute method. Okay, second question that came up today, which is completely unrelated, was about the rating bar. So you see on a user interface, we can put a rating bar on there like this, a set of stars. What do we do with it? That was the question. If I go to plant search activity, okay, and I hit Control M, this is what I can do. The rating bar has an ID called RAT Sustainability. As you see here, RAT Sustainability. What we're going to do is we're going to find the view by that ID, cast it to a rating bar, save it in the rating bar variable. After that, if we invoke getRating, that will tell us the number of stars that the user selected. And we can save that into a float, where a float is a numeric type. Okay, so a float will hold a number. It will actually hold a decimal number, so it can hold a fractional number, in other words. Now what we do is we say if the rating is greater than 3.5, we show a toast that says glad you liked it. If the rating is less than 3.5, then we say sorry you didn't like it. For an if test, the if is a conditional statement. The logic between this open and curly will only execute if this expression evaluates to true. If that expression doesn't evaluate to true, this if will not execute. An if test can stand on its own, that's all we need. But if we want to provide an alternative where we say, let's do this if it's greater than 3.5, for any other case, let's do this, that's where an else comes in. If you have an if and an else, one and only one of the two is guaranteed to execute. One and only one of the two is guaranteed to execute all the time. If you have an if, it will only execute if this expression evaluates to true. So that's basic logical logic, conditional logic rather. That's conditional logic. So those are two of the questions that have come up. Again, I welcome any of the other questions that you have. I look forward to answering them, and then I'll make a video just like this so your fellow classmates can benefit from it as well. Thank you.